Hello, my name is Xishong Ye. My topic is Static Timing Analyze. Introduction. Static timing analyze is a method that analyzes the delay of each timing path to calculate the design of the timing performance indicators, such as the maximum clock frequency or the establishment of retention time and finding time violations. It only focuses on timing performance analyze and does not involve the design of the logic function. Static timing analyze is the most widely used method of analyzing and debugging timing performance. The earliest description can be traced back to 1966. Its main purpose is to test the delay of the circuit by breaking the circuit into timing paths and calculate the delay for each path in order to check if the circuit fits within the requirement. During circuit design, it is very important to have logic structure and circuit layout. STA is the best tool to achieve that goal. STA can test the maximum and minimum delay of the circuit. A design is not finished until every part of it passes the STA. Definition. 1. STA is a authentication method. 2. STA only suits for a synchronous logic design. 3. STA only cares about timing but not logic between circuits. 4. The final purpose of STA is to find hidden timing problems and make the circuit timing closure. Timing arc. The timing method that is needed by STA is saved in cell library, and all the timing information is shown in the form of timing arc. Timing arc gives a definition to timing relationship between any two nodes in a logic box. Different types of timing arc. Setup timing arc. The setup time that defines order reaches sequential cell requires. Hold timing arc. The hold time from defined order to sequential cell requires. Edge timing arc. The delay from the defined order to clock activate or edge and output. Preset and clear timing arc. The speed of data clear when a clear signal is sent. The arc is usually cancelled because it might cause the signal path to generate a loop which is not allowed in STA. Recovery timing arc. Before the clear signal is sent, the time that clear signal is not allowed to be activated. Removal timing arc. Recovery after the clear signal is sent, the time that clear signal is not allowed to be activated. Timing constraint. Timing constraint is the rules given by user to test the design circuit. One of the most important elements is the description towards clock. In a synchronous circuit, the delay between buffers must be less than a clock period. Once clock format is decided, all the timing constraint between buffers would be decided. The property of clock contains waveform, latency, and the definition of uncertainty. Waveform defines the period and the rising dropping edge of the clock. Latency defines delaying time, and uncertainty is the time floating of the signal. Boundary conditions. Besides clocks, boundary condition has to be described. Here are several ways to define boundary condition. 1. Driving cell. 2. Input transition time. 3. Output capacitance load. 4. Input delay. And 5. Output delay. After all the boundary conditions are defined, all the path that was mentioned before could be regarded as flip-flop to flip-flop path. Once clock is settled, all the timing constraint would be automatically set. Due to the fact that each path has timing constraint, all the timing analyzes are able to run. Dynamic timing analyze. Dynamic timing analyze and static timing analyze are not alternative versions of each other. Dynamic timing focuses on the given simulation of the input signal waveform, then provide corresponding output signal waveform based on the functionality and delay of the design. DTA is mainly used to verify the logic functionality of the design under the actual time delay. DTA cannot provide the timing performance such as the maximum clock frequency. The advantage of DTA is its accuracy. Also, comparing to STA, it fits more design types. DTA flaws. 1. DTA's analyzing speed is very slow. 2. DTA requires the use of input vectors, which makes it possible to miss some critical path during the analysis due to the fact that input vectors are not necessarily sensitive to all relevant paths. 3. It is impossible to generate a complete test vector to cover all the paths, which means some timing error might not be able to be detected. Statistical static timing analyze. In the past years, STA has been a good way to analyze this circuit in order to prevent unnecessary design and help improving the efficiency of the product. However, when the geometric dimension narrows down to 45 nanometers or even smaller, timing analyze become very difficult. With the increasing number of processes in STA, the case might be very complex to solve. The reason why such difficulties are occurring is because that it is extremely difficult to implement process changes in advanced technology nodes. There are mainly two types of changes, from chip to chip and the change inside the chip. These two changes can be further divided into two categories, systematic change and randomness. SSTA tries to solve these changes by using probability distribution. Basically, SSTA is able to compute the probability function, which can lead to calculating the arrival time of all the signal at each node. If the design reaches the specified frequency, it would be calculated based on the probability distribution function of the arrival time. Conclusion: with the growing desire to having better and better efficiency on the circuit, a method was invented in order to test the design more efficiently and accurately. The method is called static timing analyze. Static timing analyze can only analyze timing requirements and cannot perform functional verification. No test vectors are required and can be analyzed more quickly than dynamic timing analyze. Static timing analyze can only analyze the synchronous circuit, but not on the asynchronous circuit timing analyze. But it can verify every path, found the timing of major issues such as the establishment of time and hold time conflict, slow path, and excessive clock offset. Actually, I made a mistake. Could be no test vectors are required and can be analyzed more quickly than static timing analyze. Static timing analyze can greatly improve simulation time and has 100% coverage over all paths. It increases the speed by pre-computing all the delays, include internal gate delays and external line delays. Static timing analyze is not simply adding up all the delays, but through the introduction of truth table, analyzing of all possible input through the path, and identifying the false path at the same time. However, due to the deep submicron process conditions. Static timing analysis cannot include all the factors that are affected by delay. Thank you.